Hello, today we're going to create a Pandas data analysis project using UV. UV is the new latest Python package manager. So for that you have to go to the UV website and install UV, and then UV will check the version. So currently we have a UV of 0.11. So using UV we can create a very nice data analysis project which is shareable and also Git installable. Let's see. So for that we are going to use a UV command. So UV has got various commands. So we're going to use the init command, which is mainly to create a new project, and then we're going to use the UV run to run the script, and then also we will use UV sync to update the project's environment. So you can also use UV tree to display the dependencies of the packages that has been installed, and you can use the UV Python for managing your Python version and installation. So you can install Python 14 in one of the project, and also you can, if you want, you can increase or downgrade your Python from 3.14 to 3.10 or 11 depending on the project. Let's see how to start. So for that you use UV init and the name of the project. So my Pandas project. So now it has created a folder called my Pandas project. So we are going to get into the my Pandas project directory and check what has UV created. So UV has created a readme file and a main.py and also the py project.toml. So this is where all the Python packages and other descriptions will be mentioned. So the structure of this file would be the name of the project, the version, description, and readme is there. Though requires 3.14. So under dependencies, so we're going to install Pandas, NumPy, IPython, and Cbon later. So let's see what else it has installed. When we run uv.init, it has not only created main.py, pyproject.toml, so it has also created a Python version. This is where your Python 3.14 would be installed, and there is a Git as well. So now after you create this file or the folder, so we can just say UV sync. So after you create after you type UV sync, so it has created a virtual environment at .vnv. So let's see .vnv. So using this .vnv we can isolate our MyPandas project using source.vnv and go to bin, and then we are going to activate this MyPandas project. So now we are an isolated virtual the environment system. So using here, so we can add and delete our project dependencies. Like for example, I can install Pandas using UV add Pandas, and then it is going to install Pandas and NumPy and 6 and Python datutil. So now we can open this uh, Py project and check what has happened. So now we can see that it has installed Pandas 3.05, which is the latest one. So similarly, we can also add for me IPython and then NumPy and then Cbon and then matplotlib. So these are the packages that I would require to create any of the data analysis project. So now we're going to look at PyProject tuml. So now we know that it has created, it has installed IPython 9.16, Matplotlib, NumPy, Pandas, and Seaborn. So these are the 5 dependencies or packages that we would require to start any of the data analysis project. So after you do this, so we can also say we sync, and now it has synced all the dependencies, and this is how we can start doing the data analysis. So now I'm going to open IPython. So this is going to give us IPython kind of a terminal IDE. So here we can import pandas as PD, and then we can also import NumPy as NP, and then we're going to import Seaborn as SNS, and then we're going to import matplotlib pyplot as a PLT. Okay, so once we do this, we are now ready to start doing our data analysis. So now, since we have installed pandas and also imported pandas as PD, so we can use PD, we can use the various functions of PD, which is all these things like read underscore CSV and read underscore XL. These are the 2 things that we're going to use today. And then we can also use read Parquet file and read JSON. And if we need, we can use this read underscore stata. So let's try to download and also read some of the CSV files first, and then we can use read underscores XL to read some of the Excel files from this website. So this is the Humanitarian Data Exchange or harmdata.org. So here we have these Excel's files from Palestine conflict event. So we're going to download one of them. So let's download this Python Palestine HRP civilian targets events fatality. So you can directly download from here, or you can just click here and have a preview on HTX. So this is going to give us the preview in the web browser itself, so you don't need to download any of these files to your this thing. So this Excel has got 2 sheets, TOU. This is the 0 sheets, and this is the second sheet where there is some data of this one. So we're going to copy this link, and then we come to our IPython. Then we're going to write PD underscore read, and then select Excel, and then we're going to paste this, and then we're going to say an option of sheet name equals, we can either use as 1 and 0. So I think in this example it is second one, so let's put sheet name as 1, or we can use even sheet name as data. That is what is in given there, right? So let's put sheet name as data, and then close the bracket, and then let's see whether it's going to read the Excel sheet. Okay, so now this is one of the most common thing that you will face when you are downloading this Excel. So you'll have to install another module or a submodule called OpenPixel. So for that we're going to add UE, add open pyxl, and then now we're going to try to read again. Right. So now we have read the second sheet of this thing, but it has not been saved. Let's save it as a data frame, as a df, which is the most commonly used variable name for any of the data frame. So so this df is going to contain a data frame of our Palestine HRP civilian targets, events, and fatality. So, so we see that this data frame has got around 10 columns and 2048 rows. And then now we're going to also try to download this CSV, which is coming from this food price WFP food prices 2022. So let's copy this link, and then so let's go, and then we are reading now PD read underscore CSV. So since it is CSV, so we need to be okay. Let's close this. I think something happened. So PD read underscore CSV, and then we're going to paste this CSV, and then we'll see. I like to see the data frame before I give it to the variable, because sometimes it gives you an error. So this WFP data frame has got I don't know 200,000 entries, so maybe it may take a while to download. Let's wait and watch. And then we are also going to uh, read some of the other Excel files from DRC. So this is the demonstration event from ACLED, and then we're going to read this health. It's called access to healthcare. It's called Safeguarding Health and Conflict Coalition, SHCC. So this has got the data on the first sheet. So the sheet name would be this one, or 0, and then we're going to use this DRC targets fatalities. So let's see. It's still downloading because it's around 200,000 lines of code. 200,000 lines of rows, not codes. Sorry. So another way of downloading would be we can stop this, and we can use wget. So that is downloading the file directly from the wget command. So this will be faster, I believe. So this is going to download to the local folder, and then we can read a CSV from the local uh, from the folder that has been saved. So maybe I think it's around 30 or 40 MB. Right. Let's wait. Okay, once we download this CSV and Excel file, so we are going to do a very basic data analysis of starting from Palestine. So we're going to look at the target events, and how many have died out of the incident, and what are the fatalities, and from we're going to look at uh, the district wise and also the sub district wise, and also we can analyze month wise, year wise, and group according to the districts, that is West Bank, Gaza, and also sub districts. And then we also can do some of the basic descriptive data analysis and transformation. I think it's around 30 MB. My Wi-Fi is a bit very slow here. Okay, we're almost there. All right. So now using wget, we have downloaded this to our local folder. So and it has around 27 MB. So now we can use pd underscore read underscore csv, and then we are going to look at what is the name of the folder or the file, which is alright, pd underscore csv, and the name of the file was or is WFE food prices. And then yeah, so now we have 207,000 rows and 17 column. So this is WFP food. Okay, so now we have WFP food as a variable, and we have saved Palestine as data frame df. And now let's go to one more which is from the SHCC. Let's copy this one, and then we will, let's see what's happening. Okay, and this is PD. It's an Excel file, so we're going to use pd.read underscore Excel and the link. And now we know the sheet. Okay, we missed the colon there. Now we're going to use sheet name is equal to either we can say 0. Let's see what happens if I do 0. So when I do 0, it's going to take the first one, and if I say 1, so it's going to take the metadata 1. So what we need is the first sheet. Okay, so it has read the first sheet. So let's save this as SHCC as the data frame variable. Okay, instead of sheet name is equal to 0, so you can actually copy paste 2023 space HCC space incident space data. So instead of copy pasting the lengthy sheet name, so we can just say either it's whether it's a sheet 1, sheet name is 0, 1, 2, 3, 4, 5. So also you can just test if you are not aware of the number of the name of the sheet. You can just experiment, start from 0, it may be a metadata or a data, and 1, 2, 3, 4, 5, and then if you don't want to download and open it, so you can just experiment like that. So now if I say SHCC, so it has given me 2278 rows and 26 column. So that is how you download CSV and Excel. So for reading the CSV file, so there is a whole lot of other parameters that you can use with read dot underscore CSV. So we know if there is a CSV which is separated by tabs, so we can say sep is equal to tab, or it could be other separators. Sometimes somebody has used a colon or semicolon or even an underscore, so you can use that. So then you can also say I only want to take use calls using use call parameter. We can say that I only want particular columns, maybe name, age, and country, and then you can Also you can include true values, and then remove false values. Also you can use this interesting thing. Some of the CSVs have got footer, so we can say that skip footer is equal to 0, and also you can skip some of the rows. Maybe I think if the second row has got some other an empty row, then we can say that the second row you can skip that. And also we can use this NA underscore values to not include NA values. By default it includes all the NA values, so we can say that if you want to remove all the NA values, you can say NA value is equal to true. And then we can use this one, which is past dates. So if you already know a column which is in a date format, then we can say that or not in the date format, then you can say that pass that column using past dates. And then we can use other thing. I think this is one very cool stuff, which is chunk size. So if your data frame has got around, if your CSV has got around 100,000 or 1 million rows, then we can say that instead of reading all the 100,000 or million, you can just say that okay, I just want to read 10,000 or 100,000 in a chunk size wise. So then every time you read, you can just read a sample of 100,000 or 10,000 chunk size, and then subsequently you can create some other functions to read every time 10,000, 100,000 each. And then there are other things that you can explore, like thousands and decimals, and these are some of the commonest one that I use. And you can just go and read def underscore read underscore CSV. Everything is here, and also some of the examples are here. So just copy these and experiment with this thing. Like for example, you can use pd dot read underscore tsv, and the name of the CSV. Then you say past dates of the column 1 and 2, and then the format should be this one. Column 2 should be in this format, and excuse me, column 3 should be in this format. You can also say that something like where is it? Okay, yeah. So pd dot read underscore CSV. So name of the CSV, and then you say NA values foo and bar. These are the NA values. So then it's going to ignore those things. So that is read underscore CSV. So similarly, we have read underscores Excel. So let's see what all parameters read underscore Excel has got. So as we know, we already use a sheet name. So either you can use a string, that is the name of the sheet name, or the integer, that is 0, 1, 2, and 3. So by default it is the first sheet, which is 0. So if you want, you can just add 1, then it's going to read the second sheet. So also the header, by default it is none, that is 0. So we can say that header can be maybe first row. And then you can use these things, like for example engine. You can mention I want Calman engine to be used, and then the most common would be skip rows. So you can say sequence, like the first 10 rows, that is 0 to 11, you can skip them. And then you can say n rows, so number of rows, how many rows you want, like maybe 10 rows only, are 100,000 rows. So and then this is another one you could explore, that is past dates. So it could be in a list format, or a dict format, or a boolean format. So also you can using this read Excel, you can also not only use Excel X, so you can use XLM, XLSB, ODF, that is open data format, and ODT extensions. So have a look at this, like for example a sheet name. So you can say by default is equal to 0, the first sheet of the data frame. and 0 to 1 on sheet 5. You can also load the first and the second and the sheet name called sheet 5. So you can read 3 sheets at a time. And then let's now we know that we have uh, uh, read few CSV and other stuff. So if you don't know, now if you already forgotten what variables or the data frame names that you given, then you can use dir command. So it's going to give us all the data, the variable names that we just given to the various CSV imports. So one I think with is the df, it is from the Palestine, and then we have something called as a shcc, and when we have wfp food. So now we have df, shcc, and then wfp. And also, like for example, if I don't like wfp, we can just use the tab, so for selecting wfp food. So it's going to give us wfp food. So let's take uh, this first data frame of Palestine and examine this particular data frame. So now by just typing df, so it's going to give us a overview of all the rows and the columns. So in this one, it has got 10 columns and then 2048 rows, and each of the row has been given an index starting from 0 to 2047. So that is 2047 plus 0 is equal to 2048 rows, and it has got country, admin 1, admin 2, ISO 3, admin 2 P code, admin 1 P code, month, year, events, and facilities. So now some of the basics that you have to do to understand this data frame is start from what is called as a df.info. So it's going to give us the information of this pandas data frame. So we know that this is a pandas data frame, and the range index is 2048 entries, 0 to 247 2047. So, and there are 10 columns, and then these are the column names, and then there is a data type of this column, and then a non-null count. So we have 2048 entries, and every column has got 2048. So there are no null values in this one, in this data frame. And also it is going to tell us what are the types of data types in this data frame. So we have three int 64, that is year, events, and fatalities, and then there are strings. There are 7 strings. So country is a string, admin 1 is a string, admin 2 is a string, ISO 3 is a string, admin 2 is a string, and month is also a string. So month is a string because it's in January February format, whereas the year is in int. So maybe we know that this can be converted to a date format. We will see in the future how to convert that. Okay, and then we know events and fatalities are integers because they are all full numbers. So if it were to be 10.0 or 1.8, then this would have been not integer, but it would be a float. So, and it is using around 160 KB memory. Okay, so once you use df.info, so the next one would be df.dtypes. So df.dtypes, it's going to give us only about the data types. So we know that we already know these are the strings and these are the integers, so which is also the same information that we got it from df.info. So after that we can use something called as our df.index. So df.index is going to give us what is the type, the kind of index that has been used in this one. So in this one it has got a range index, so starts from 0 and stops at 2048 and at a step of 1. So since it's a range of integers 0 to 2048, so and it is increasing by 1. So sometimes if the index is let's imagine a month, then here the instead of 0 to 2047, so maybe the index could be month or the index could be year. So after index, so we can use something called as a ds describe. So ds dot df dot describe will give a description, or it is going to give us descriptive analytics of year and events and fatalities, which are the integers. So it is not going to give us anything about the string, which is that is not what is required. So in this one, so it is going to give us descriptive analysis of a year. So we know there is 2048 count of events fatalities, and the mean of year is 2020, and then the mean of events is 14 events and 26 fatalities, and then we got standard deviation of 3 year, 26 year, 152 year, and we know the minimum is 2016, and the maximum is we got 2026. So we got data from the past 10 years. So, and also we know that the 50th percent of this one for the year is 2021, whereas here the 50th percentile is 5 and fatalities is 0. Okay, and also we know that the maximum fatality is 3280. We're going to look at in which date or which particular place this 3218 fatalities happened. Okay, so once you do this one, so we can look at other aspects, which is how do you select the columns, and how do you select each row. So for selecting one column, so I'm selecting multiple columns and ignoring some of the columns, and how do you select the particular rows and the range of rows, and then also how do you drop some of the columns, how do you drop some of the rows, and let's see. So now we have this df, so using df, so we can say if I want to select only the first column, that is country, then I can use this bracket and the colon, and then I just type the name of the column. So now which has got, I selected the country column. So similarly I can also correct is there a age, the year. So similarly I can select year. So similarly if I want to select multiple columns, so now if I want to select year and also month, so if I say that year and month like this, it is going to give me an error, because we need to give put these two things in a list format. Then we can choose as many columns as you like for example, now I have selected month and the year, and then I can say that I want events, and then maybe I can just instead of admin this thing, so I can say that I want admin 1 and then column, so then it's going to give me only these 4 columns. And then if I want to save this as only events data frame, I can say that I can give a name of data events and equals, then and I say df, it's going to give me all the 11 10 rows. Now if I say df event, so it's going to give me only the events of admin 1, year, month, and events. So similarly I can just do fatalities. Okay, so I can say fatalities. So now, so if I go back to df, I can rename this as df fatalities. Alright, so now we have df events, and then we have df fatalities. Alright, so now we have made 2 more data frames from the main df data frame. So one is for df events, and another one is df fatalities. So now if I see dir, so now I should see my these 3 data frames, so df and df events and df fatalities. So similarly now let's see how do I also instead of just giving uh, column names like this, instead of what if the column names are very long. So for that we can use something called as df dot ilog. So this is an index based location, so we can say you can give index saying that okay, I want the first column. All right, it says okay, it's going to take only the first data element of this, the whole the row, that is Palestine, West Bank, Al Quds, Palestine, Gaza Strip, or this one 01, the first one. So Palestine, Gaza Strip, Rafah, PSC, PS2, PSO2, January 26, and 00. So it has only selected the first row of this data frame. So now if I want uh, uh, 2, then it is going to give me uh, the 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 0 1 and 2, that is the admin 2 Rafa data element of this first row. So similarly I can say df dot I location ilog. So now if I say column, if I put a colon, then I say close the bracket. So basically it is going to give me everything, all the rows on the column. So now if I say colon and then if I say 1, so it is going to give me the first column or the sorry the the first column, not the first one, the first and the second column of df, that is West Bank, Gaza Strip, all of those things. So now if I want uh, uh, 3 columns, then I can use something called as a uh, list here. So I can say that give me all the rows of df and the second, third columns. So what has happened here? I think okay, let's see. Okay, so now if I say 1 colon 3, so it has given me all the rows and the first and the second. So if I say now 0 to 6, so it's going to give me 0 1 2 and 3 and 4 and the 4 columns of that. So now if I see that I want something from 0 to 8, so it's going to give me almost all the columns. So if I say 0 to 9, so it's going to give me 1 2 3 4 5 6 7 8 9 columns. So that is 0 to 9. So similarly if I don't want all the columns, I just want only a few rows, that is I want something like the 10 to 20th row. So now I have rows only from row 10 to 20 and then 0 to 9, that is from 0 to 9, that is 8 columns, that is 1 2 3 4 5 6 7 8 9 columns. So similarly we can just reduce for simplicity. So I just want only the first 3 columns and the 20th row. So similarly we can say that I want only 31st to 51st row. So now it is going to give me 30th to 50th row. So this is how you use iLock to select some of the rows and some of the columns. So similarly, we can also use like for example using iloc. So we can use something called as a start colon colon -1. So what it does is it's going to reverse the whole data frame. So this 204147 would be the first the zeroth the row, and the zero row would become 20 the last row. So and okay, we made a mistake here. It's ilog. So now all the rows have reversed. So if you want, you can also save this as df underscore reverse, and then we have another row, another data frame of df underscore reverse. So now we have done column selection, we've done row selection, and we know how to select some of the rows and some of the columns. So similarly, we have something called as a df called location. So this is mostly a location based selection. So like for example, I can select a country, like if you don't know exactly the column index, so then we can just use df.log, and we can select only the country. So now for that we need to give all the rows, and then it is going to give us the first country, and then we can say that and then I need second column, which is here. Then I can say that I also need events. So it's going to give me events, and I can say that oh, I don't want events at the end, I want fatalities at the beginning of this one. Then I can say that the fatality. So if you don't like year in the middle, so you can say that I want year in the middle. So now it's going to be in the first. So now we know how to select uh, this. We can say that this is year, df underscore year. Okay, so now we have made a sub data frame using the main data frame. So 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 once you do iloc and lock, and the next would be is to look for the column names. Okay, so we can use something called the df dot column. So it's going to give us all the names of the column. So it's going to be in a list, and there are strings. So so after that, so let's see what else can we do. So using so now, like for example, if I want only if you want to test how many unique names are there in admin 2, so for that, so we already know how to select our admin 1 column, right? So we know how to select our admin 1, and on top, or if you want to see how many unique names are there in this admin 1, so we can use something called as unique method here. So we can say unique, and it is going to give us, there are two unique names in this column, which is West Bank and Gaza Strip. So we can also say, instead of unique, so we can say n unique. So then it's going to give us two names. There are two unique things. So similarly, we can go to admin 2 and see. So in admin 2 there are 16 unique names, that is Al Quds, Rafah, Tubbs, Gaza, Khan Yunis, and Jenin, something like that. So there are 16. So we can also use n unique. So it's going to give us 16. So we know how to do that. So similarly, we can now look at how many unique years are there. So we can use something called as df, and the name of the column would be here. And now we are 11 unique names. So there is, so 11 years, the past 11-year data is there. Okay, and then we know, and if you see the country one, so it will be one unique name, which is Palestine. So similarly, we can look at a month. Like for example, I can go to month, and then I know that there are 12 unique months in this data frame. Okay, once we do a unique names of the admins and the months and the year, so now we can look at DF. All right, let's start from the beginning. So let's imagine we want to select only 2026 year data from this data frame. So we can use something called as a data df dot query, and we can start with double quotes, and we say in the year equals 2026, and then close quotes and then close bracket. So now it's going to give us only the rows that contain 2026 data. So we have around 128 rows from 2026, so we can save this as 2026. So we can't save it as 2026 because it's going to give us an error saying that hey, we can't uh, use 2026. So we can say that it is year 2026. So now we have a data frame for 2026. So this has got all the rows of 2026, but you see that it has taken the index from the previous data frame. So we can reset this index from 0 to 127. So for that, what we can do is here we can say dot reset index is equal to reset index. You can say reset index, and then it's going to give us 0 to 127, but it has got this index column. It has kept the previous index, so which is of no use to us. So we can say research index is equal to we can say drop equals true, and it's going to drop that index column, and then it's going to create only 0 to 127. So this is a very useful tip you can do. Like you can say that I want only 2026, but reset the index. So not only reset the index, but you also drop the old index of the previous one. So once you do this, so we have got this new data frame of 2026 year. So we can save this as year 2026 data frame. So if you see now 2026 data frame, so this will be having index from 0 to 127, and only from 2026. So similarly, now you know you can only look at West Bank and Gaza. Like for example, for that we start with the df query instead of year. So we'll use admin1 equals now we can say we want only West and Bank, and then it's going to give us all right, this is what you need to know is you need to close with a double quotes as well. So now it's going to give us all the data from West Bank. So similarly, now we know what to do is equal to we know reset index, and then drop is equal to true. And now we have df West Bank. So okay, so now we have df West Bank. Okay, so similarly we can just say df what is there, Gaza strip. Okay, Gaza strip, and then we can say df Gaza okay strip. All right, now we have West Bank, and then we have Gaza Strip. All right. Similarly, what else can we do? So we can now, let's imagine we want to see only from Rafah. So for that, you know now what to do. So we'll go to Rafah, and then we'll change from df1 like admin 2 from admin 1 to admin 2, and then we say df rfah df Rafah. So now we say df Rafah. So we have only data from Rafah for all the years. So now we have got various slices of data frame from this main data. So now if you start with df and then start with df and then the subsequent sub data frame, so all of them will be here. So when you want, you can come back and see, oh, from df I got events, fatalities, Gaza Strip, and from only for Rafah, and then there is one on rivers, and then there is West Bank. And yeah, let's imagine also if we don't want to keep this df underscore rivers, we can just delete that by typing df underscore rivers, and then that will be removed from your memory. All right, so now we have this, and then we have what else we need to do. So let's group according to the years and the fatalities and the events. So for that, what you can do is there is a function called df group by, and then we're going to use maybe year wise we're going to group this one. So once we do this df dot group by year, it's going to give us a data frame group by object. So on top of this or over this object, we can say that now you group by these events. So let's say every year grouping of the event. So now it has done not only data frame group by, now it has created something called as a series group by of year and event. So on over this, so now we can use either the sum or the mean, okay, or the count. So let's see, let's start from the sum. So now we need to we should see the events year wise. That is in 2016 there are 216 events, and then 2024 is 6094, and 2025 has got the largest event. So now, so we know the year wise group by. So now we can sort these values as ascending or descending. So if I say sort values, so it is going to start from the smallest to the largest one. So if I don't want, then I can say ascending equals false. So when I put ascend equals false, so it is going to start with the largest number. So we know 7,715 events happen in 2025, and the next one happened in 2024, and the lowest was in 2016. So if you want, you can also save this as df group by year wise. All right, so now we know df group by year wise. So similarly, we can do this for fatalities. So we can save this year fatality. So we have to rename the previous one as only the events. Okay, so let's now see df underscore group by event. So we know 7,700 events. So and then let's see the fatalities, right? So let's see. So fatalities happened around 20,000 people died in 2024. The second one is 2023 and 2025, and the lowest was in 2020. So we know from 2021, so it is increasing steadily. So now we know that. So now we've done it according to here, and then now we need to see the fatalities according to the admin tool. Let's see for that. So we can go back and just do the same thing. Like for example, fatalities, you can just remove here and then add admin 2 and then group by admin 2 and down. So we know group by admin 2 fatalities. So we know now. So highest fatalities happen in Gaza City of 18,000, then Deir el Bala 11,000, Khan Yunis 9,000, then Jericho other 11. So similarly, we can look at the number of events and admin 2. So so which will be df underscore group by underscore admin 2 underscore events. Okay, so we know now df admin events. Okay, so now we know that Gaza City had 4,000 events and Jericho had 392 events. So now we're done analysis of admin 2 and then here, and now let's see which month has got the most fatalities and most events. So for that, again, we can go back to this one, and then instead of events we just put as a month, and then instead of admin 2 it'll be month wise. Okay, all right, so now we know it cannot happen because it cannot do because our month is in a string format. So for that, maybe I think what we can do is we can reset index, and we can say that instead of 1 2 3 4 integers, so let's keep month as okay, so we say df and let's see whether this is going to work. Reset index, is it pd dot reset? Okay, it's df dot reset index. Let's see whether country happens. So it should work as a country and not match index name. So it's going to be dx. Okay, so that's some issue over there. Let's see what is the problem. Okay, let me check whether it works with ISO 3. So if you get into any mistakes like this, so you can just look at the help or the man page of df reset index, and then level, you can read a bit and then try to, like for example here, so I can reset index, okay, and then reset index name and then level class. Okay, reset index. Okay. Okay. All right, let's drop this one. So what else can we do now? Okay, on top of this, so we're done month wise, year wise. So and then Gaza strip, and then What else can we do? Okay, let's check data type. Okay, so this is one way of doing, since also I'm not completely prepared for this one. So till this I can do over the top of my mind. So maybe I think I'll have to refer some stuff. It was very easy to actually put. It's not reset. Okay, it's set index. Okay, let's see. I think it's set index. Okay, it's reset. Where we've been trying to resetting the index. Instead of that, we can say reset index is now. Okay, so no, yeah, it's not set reset index. It is set index. So once you set index to month, so now all the index is now to set to month. Okay, so now we have to save this as df. Let's see, I'll just save it as df1. Let's instead of doing, like for example, for df we got index of 0 to 2047. For this one we have a month as index, so df1 into index. So if we do index, so it's going to tell us that, oh, it has got only the indexes. Okay, all right, so now I think where were we? I think we did something called as all right, here, right? So instead of df, we'll just put df1 and see whether it's going to work. No, it's not going to work again. Okay, anyhow, I think so now let's okay, that's about the Palestine the Palestine data from here. So now we're going to look at let's see, maybe WFP data frame, and that will be WFP food. So, so WFP food is something similar to Palestine data. So we start with info WFP food. Okay, so WFP food dot info. Okay, so now we got so many strings, int and float, and then these things. So we know now. So for me, it's always better to use something called df2 or df3, which is easier for me. So now I reassign WFP food to df2, or you can also do something called as df2 dot copy. So now it's going to give me a different data frame instead of that one. So now we have a backup called WFP food, and then we're going to experiment on df2. Okay, df2 describe. So and then df2 dot info, and then df2. All right, let's see the price of df2 dot group by, and then we're going to look at country ISO. Let's see, country ISO 3, and then let's look at the price. Instead of sum, we'll just see the mean price. So now we know. So Afghanistan 124 and Zimbabwe 2.3. So we don't know how to sort. So we'll say sort values equals ascending equals false. Now we start from Iran to 0 and Nico I think it could be Nicaragua. Okay, and then if we just see, then we just say, okay, Afghanistan, Armenia, something like this. So now we have df2. All right, then also we can look at market. I think it is market. Let's see. Okay, so now we have got price from all the markets. That is, there are 2,300 markets, and then we can also look at admin 2. What's happening in admin 2? Okay, so that's how you do a group by, and then we can do something called as df2 dot filter. Okay, so we have not checked this. Are there any NS in this data frame? So we're going to check that using is NA. Are there any NS, and also give us the sum of them. So in this one, so there are 134 NS in admin 1, 134 in admin 2, and longitude, and also US dollar price. So we don't know, and you can actually sum the sum of these, which is going to give us there are 1100 a frame. Then we can say df2 dot is duplicates. Are there any duplicated one? So now we can, it is showing a lot of false. So let's see, are there any duplicates? No, there are no duplicates on this one. So, and then let's imagine df2 dot is na, and then we know that this latitude has got 134 data is na. So we can check what type of NS is that. So we can say that latitude. Okay, it's actually not available, but these are all minus coordinates. So I think it is taking all the minus coordinates as NA. So maybe let's check at USD price. Right. So E is NA, and now we can check whether which are the rows. Okay, so USD price. So these are the rows that doesn't have a US dollar price, but it has got price in price. That is maybe the local currency price. So if you don't want this thing, we can just actually drop df2 dot drop and USD price and see what happens. So it says no axis, so we'll have to define axis is equal to 1. So 1 is the columns and 0 is the row. So now the US dollar price is gone, so we can now save this as new data frame without the US dollar price. So that is how you actually import and explore some of the data frames.